Alrighty, so wow, this is getting ridiculously windy. So I'm going to go over the unit test that is next Friday. This is super windy, and I'm going to talk about what is going to be on the test and what you should be preparing for and expecting. So what? Okay. So in this case, there is a document. There's a Google Doc. I'm at the link.
All the questions you need to do.
No, not all the questions. Just what kind of things you do need to know. So link. No, that would be bad. That would be bad. Okay, so in terms of the tests, couple of things. First off, again, the total test I'm aiming for 45 minutes, roughly. Okay, 45 minutes. So in this case, multiple choice, roughly 30 multiple choice, plus or minus 5. Okay, plus or minus 5. There will be 3 to 5 written questions. Don't restart. Yes.
Can we have minus 5 questions and plus 5 minutes?
That's awesome idea. So should I, in that case, plus 5 questions and minus 10 minutes on your test, on your exam? Something has to come from somewhere, right?
You can do that to the other class.
That would not be fair. Anyways, coming back. So roughly around there, okay? Roughly around that range, you will need to know Punnett squares, meiosis, pedigree chart, DNA, and mutation, okay? Those will be the written section. Now, in terms of the coverage, now, this is a little bit old. This is the updated one. Now, the different conditions, different Punnett square conditions that you should know, I believe there is a document here already. We generate that from yesterday. So in this case, please refer to it. Okay, please refer to it. Again, there are some, based on today's, how much I got done with the other class. I haven't really had a chance to do these 4. However, you should know that cystic fibrosis is autosomal recessive. Okay, so these would be autosomal recessive. Okay, these are autosomal, not recessive. These are autosomal. Some are dominant, some are recessive. Okay, purple flower, white flower, Mandel's experiment. That is, you should know. Snapdragon color, that's an example of incomplete dominance. You should know. Blood typing, sickle cell codominance, and the sex-linked recessive ones are here. Okay. Also, you will be expected to detect or determine whether a certain condition is autosomal recessive, autosomal dominant, codominant like blood type, or sex-linked recessive based on the pedigree chart. Okay, so the 4 different types of inheritance that you should be able to detect from pedigree chart will be autosomal dominant, autosomal recessive, codominant like blood type, and sex-linked recessive. Okay. Yes.
Is there any practice for that?
I'll look and see if I can find some. Okay. Questions? Now, going back to what is on the tests or the coverage and whatnot. So here, 4.1 to 4.4, okay, 4.1 to 4.4 genetic material, either sexual reproduction, asexual reproduction, the advantages of both. Okay, so that is the main part of it. Okay, that's going to be on the test. Asexual and sexual reproduction. Asexual and sexual reproduction. Let me look back at this first. So, okay. Asexual reproduction, you guys should have a handout on this. A lot of it is very, very familiar. Now, the key things is interphase, cell cycle, and mitosis. Interphase, cell cycle, and mitosis. Okay. So that's the main part of it. Make sure you know how does it look like at which stage. If I remember correctly, last year there were some like multiple choice questions like, hey, this is a picture of a cell. What stage is this cell in? And you have to guess or you have to pick the correct one. Okay. Now, cloning. Cloning-wise, I'm not going to go too far beyond what is on this handout. Okay. We did spend quite a bit of time talking about Dolly because a lot of people were interested about Dolly. So we did talk quite a bit about that. So do expect this is on it. But in terms of the rest of the stuff, I'm not going to, from the textbook, I'm not going to go as in depth simply because we talk about cloning when we're talking about plants and diversity. So we're not going to go much more deeper than that. Okay. So that would be 4.2. And 4.3, sexual reproduction. When we're talking about that part, when we're saying sexual reproduction, we really were talking about meiosis. Okay, we really were talking about meiosis. Okay, so this set of handout. Remember, we also drew some diagrams of what's going on per each stage of meiosis. Okay. Per each stage of meiosis. So make sure you look at that. If you look at the unit planner, I did record the video in terms of the meiosis lesson. Okay, the second half of the lesson with a lot of the drawing that was done, and I was quickly doing a recap. Okay, so in this case, you can watch that video double speed if you want. I won't be insulted. But make sure you know the little blurb per section, okay? I said to the other class, next week, Monday or Tuesday, I might give you a very short quiz, like 3 to 5 minute quiz on meiosis. Okay? So, written. 3 to 5 minutes. Okay. So in this case, make sure you know about meiosis, what happens at each of those stages. Let's see. That's the wrong one. Now, abnormal meiosis, this one we're going to be talking about today. Okay, we're going to be talking about that today. We're not going to do 4.5. That's not going to be part of our test. Okay, absolutely big no. 5.1, Mendelian genetics. That's our introduction to the Punnett squares and stuff. Now, for this one, let me find that part. for the Mendel's notes and whatnot. Now, that particular handout on Mendel's notes is, where is it? Not here. Oh yeah. This section of this handout, a lot of it by now, because remember, we were really just learning through this handout, learning concepts like Punnett square, learned a little bit about history of what Mendel did, learned a whole bunch of definitions, right? Definitions like alleles, gametes, homozygous, heterozygous, test crossing, and so dominance and recessive, right? So a lot of this, you probably know that by now. The one nice thing about this unit is that if you do enough Punnett square, a lot of those concepts you will know down pat. So the stuff that I would suggest you look at in this package is two things. You have this package before, and you also have this package. And in this package, there's a list of terms and definitions and examples. Double check. Are there anything on here that's not on this list? Okay. I don't think so, but just double check. Okay. Obviously, this is not my handwriting. The other thing from this handout would be have a basic idea what on earth Gregor Mendel did. Okay, what did he do? He experimented on pea plants. Now, you don't need to know the binomial name of pea plants. Okay, you don't need to know that binomial name. You should know what is true breeding, but it's also covered in this document here. Now, someone, I believe in this class, did ask, like, hey, you haven't tested us on plants yet. How much on plants do you need to know? I would say nothing beyond this frame. Basically, how on earth did Gregor Mendel either cross-pollinate plants or get plants to self-pollinate? Okay? So that's as much as you need to know. That's also one reason why it was a pretty good introduction to genetics. Okay? Are we good? Anything else? Know the law of segregation. Mendel's law of segregation. I don't think it's really written on this handout right here. Essentially, if you have genes or traits that are on different chromosomes, what happens on one does not affect the others. Okay, what happens on one, it does not affect the others. Kind of like those, exactly like those autosomal disorders, because those autosomal disorder and conditions happens outside of that sex chromosome. It doesn't matter whether you're a boy or a girl, you have an equal chance of having that condition. Okay? If it is on the same chromosome, however, then it would be linked to the other stuff. Okay? No? Okay. Now, right after this handout, we did an activity, the make a face activity. So a lot of time was spent on it. That kind of lead us into a lot of concepts. Now, we also did this here, variation of hereditary. So we did have a handwritten note on that one, which is right. Hello. Okay. Do remind me to update attendance. Thank you. Unless they update it. So, in this case here, at this part, we did list out the variation of hereditary, what kind of things we have done and seen. So Snapdragon, again, remember, node size would be another example for in our activity, incomplete. So we did that. We at this point know blood typing and that part pretty well. I also did a little bit of notes on that one here, as well as a blood typing question. Okay. Now we also had this package. No. After that, we gone over pedigree chart. Wow, I misspelled something. Making. So pedigree chart. Pedigree chart. So we start learning about pedigree chart. We know about the symbols, about how do we draw a pedigree chart. And this is an example. So the albino example, albinoism example in terms of pedigree chart. This is an example. How do we know if, based on the pedigree chart, what kind of inheritance pattern? As I said, you expect to see autosomal dominance, autosomal recessive, codominant like blood type, or sex-linked recessive. Okay. In terms of sex-linked recessive, you would tend to see more of male being affected and female not being affected. Okay. Are we good? Now, we also, after that, we have moved on to using this pretty thick package. Where is it? Yep. So this package right here, okay? So we've done a lot of practice question. We summarize a lot of things. So make sure, again, do some practice questions. This one here, the discontinuous and continuous variation. Now, during lesson, I was like, lethal alleles, I'm going to get back to you in terms of examples, okay, in terms of examples. Now, lethal alleles, I believe when I look at the textbook, it's not in this version of the textbook. It's not in this version of the textbook. However, when I look it up, some examples will be things like this: sickle cell anemia, cystic fibrosis, and Huntington disease. Okay. Typically, lethal alleles, if it cause death. Now, if it is dominant and it is expressed immediately, that individual won't even be carried to terms. Essentially, something will happen to the embryo within that 9 months and there will be a miscarriage. Okay. And if it is dominant, like Huntington disease is autosomal dominant, autosomal dominant. If it is dominant, it will be something that happens, it will be expressed later on, so that this allele could get passed down. Like Huntington disease won't happen until like slightly like midlife or early-ish life. So there's still a chance and time for that individual, not knowing that they have Huntington disease, to have kids, and that allele will still get passed down. Okay. Now, if it is recessive, like sickle cell anemia or cystic fibrosis, then in this case, you could be a carrier and passing that allele down, or even if you are affected, depending where you live and your condition, you might still have a chance to have kids and pass down that allele. So when we're talking about lethal alleles, a lot of textbooks don't use this term, but basically you're talking about genetic conditions or mutations that will cause death. Yes?
So did you say that if dominant, they'd be like eliminated, or they get it later on, or if dominant, they'd be eliminated and then
No, if it is expressed early on, like a lot of times in utero, then in this case, that individual won't even be carried to term. There are some situations like Huntington disease is a dominant allele, is a dominant trait. So in this case, autosomal dominant. So, but it won't show up until way after puberty. Okay. Yes.
What is Huntington's disease?
Well, we can look that up a little bit later. It is actually in the textbook. Okay. Questions? Yes.
So we're doing practice questions in the packet. Some of them we provided answers for, and some of them we didn't. So.
Okay, I will try to get that done.
Okay. Thank you.
Okay. It's one of those things like mark your lab, answer questions, provide sample answers.
Thank
So,
you.
no problem. So be patient. Okay, so that's that part. Test crossing, blood typing, blah, blah, blah. Pedigree chart, sex-linked alleles. We'll talk about that. Oh yeah, so earlier you're wondering about Huntington disease. Okay, if you look at the textbook 5.5, it's in that chapter. Okay, so you can look at that later on. I will actually talk about it probably next week. Okay. Dihypercrosis. Dihypercrosis. So you guys earlier this week or so, you guys did watch the video and did some dihypercrosis questions. So make sure, do expect to see dihypercrosis questions. If you do these questions, I would ask you to at least show all the work, okay? Don't just give me two monohypercrosis and multiply and do the math. Or if something like this, at least simplify it, okay? At least simplify it based on the number of different kind of alleles there is. In terms of Punnett square wise, that's about it. I will, of course, as you see earlier, there are some conditions that I'm gonna do some Punnett squares with you, but in terms of the types of Punnett square, there's not gonna be any new ones to do. Okay? Any questions so far? Now, chapter 6, we're going to be focusing on just two things, okay? First off, the DNA and code of life. So what we talked about yesterday, okay? The structure of DNA, the composition of DNA, that's going to be on the test, as well as a little bit of history on the discovery of DNA. As you see here, one question on before Walter and Crick and Franklin, one history question on that particular period and events. Okay. Mutations, the type of mutations, okay, that will also be on the test. It is something I will cover next week. Okay. But I'm telling you guys all this now so you have time to practice. Are you guys good? Now, in terms of practice questions, I will put some textbook questions I'll put some textbook questions onto the unit planner a little bit later on. Okay, those have answers in the back, so that will be very quick to do. And also, I have some additional Punnett square questions. If you want to see this different type of Punnett square questions, there's a link here. Now, this document, yes, it's from IB Bio. Now, this document here, there are some practice problems on Punnett squares. However, I would ask you either don't do the ones that looks like they have dihybrid cross, or just be very careful and read carefully, because we have not learned about dihybrid crosses that involve crossing over. Okay, so you're crossing over, if you remember correctly, that's during meiosis, in the beginning stages of meiosis, where homologous chromosomes can cross over and form hybrids. Okay, so far in our dihybrid crosses question, we never dealt with those. There are some of those types of questions on here, so that's why when you're reading these dihybrid crosses question, be very careful, okay? Or just don't need to do them, okay? Questions? No? Okay. That's about it I can think of. Are there questions before I stop recording? No? All right, so I'm going to stop recording for this.